In this question, we need to describe the transformations that are happening from function 1 to function 2. We don't need the equation per se, but just need to describe that transformation. So to help us describe the transformation, I'm going to plot both of these graphs on our coordinate system here. And our parent function is right here. That's going to have a vertex right in the origin. It's going to curve up like this. Now, this is a rough sketch, so it's not going to be totally exact. Now I'm going to put down function 2. And the first thing I want to do here is plot the vertex. Now, the vertex is going to be h comma k. Okay? So it looks like our h value, which is subtracted from our x, is going to be a positive 2. So that's going to be positive 2. And then our k value is being subtracted at the end. That's going to be a negative 4. So I can plot that on my graph. It's going to be about right here. Now, if you're saying, well, I thought my h value was a negative because we're subtracting, well, remember, in our formula, we have the subtraction of h, so we want to do the opposite sign. So since this is negative, we want to make that value here a positive. Okay, so there is our vertex, and the last thing that we have to take into account is this negative sign in front. And that negative sign actually flips the parabola. So instead of opening upwards, it's going to open up downwards. So it's going to look something like this. And again, this is a very rough sketch. It's not perfect. Technically, both of these parabolas should be opening up at the same rate, I guess you'd say, because our a value didn't change other than the fact that it's negative. But you can see that this one kind of looks a little bit narrower. This one looks wider. That's just because I'm doing it by hand and it's not perfect. So go ahead and just disregard that part of it. So now in terms of describing what happened, it looks like function 2 was flipped, and then it was shifted to the right twice, and it was also shifted down 4. In part B, we're going to take the same approach, except it's a little bit harder because we're not starting with the parent function. We're going to start with f1 of x, and I want to plot this on my coordinate system. So like I did with function 2 in my last one, I'm going to use my vertex form along with my vertex, plot my vertex first, and then I'll add in the curves. So my h and k for this equation right here is going to be negative 1 comma 2. Okay, remember, we always want to take the opposite sign of our h value here, the opposite sign of this number here. My h value is negative 1, and then my k value is going to be 2. So that's going to be the vertex, and I could plot it right away on my graph here. I could curve up my parabola like this, and I have to say that I cheated. I looked at the graph beforehand, and I knew that this curve would actually go through my y-axis at 0, 3. So to keep this accurate, it should kind of curve up right there at 0, 3. Okay, and you can actually get that by hand by plugging in a 0 for x. Simplify this a little bit. 0 plus 1 will be 1. 1 squared would be 1, and then add 2 to it. That's going to be 3. So that would give you the actual y-intercept. Okay, on to the second function. I want to plot my vertex here as well. So it looks like my h value is going to be a positive 1, and then my k value is going to be a negative 3. Once again, remember, we're going to take the opposite of what's going on here. So it looks like we're subtracting 1, so we go with a positive 1. So my vertex is going to be 1 comma negative 3. So I'm going to go over 1 and then down 3. And that's going to be my vertex. And the other thing that I have to take into account is this 2 in front. And whenever I have a number larger than 1, it means that that parabola is going to become more narrower. It's going to get skinnier. Alright, so I have to take that into account. So when I draw my parabola, it has to not open up as wide as this parabola. Okay, now when I make this curve here, right, I know that it's going to go through my y-axis. So to get a more accurate rough sketch, I'm going to actually figure out what that that y-intercept is, instead of just blindly running it through the axis. And like I explained, adding in a 0 for x up here, I'm going to do the same thing for f of 2. So I'm going to evaluate it for 0. That just means substituting in 0 for x to get my y-intercept. So I'm going to have a 0 here, subtract 1, square it, and then we're going to subtract 3. So I'm going to simplify some of this. This is going to be 2, and then negative 1 squared, subtracting 3. We're going to have 2 times negative 1 squared is a positive 1, and then we're subtracting 3. 2 times 1 is 2, and we got minus 3, and then we're left with negative 1. So the y-intercept is going to be negative 1, because when our x value is 0, our y value is negative 1. So I know that my curve should go through that point right there. Alright, now these are a couple very, very bad parabolas. They are definitely a rough sketch, by no means very accurate, but at least you could see the transformation that's happening. So let's go ahead and jot this down. What actually happened from function 1 to function 2? Well, like what we just realized, it got narrower. So I'll just write narrower. You could also call a horizontal stretch. It's pulling apart from left and right. And then what else did it did? Or what else did it do? This was our original vertex here. So it looks like we shifted to the right 1, 2. So to the right twice. And then it shifted down 1, 2, 3, 4, 5 times. Now, did we have to plot both those parabolas? No, you could have probably done it by hand. It's just a lot easier to go ahead and plot that on a coordinate system and just see what's going on. It makes describing it a little bit easier.